a system difference equation.
Mhm.
Yn equals 0.7 yn minus 1 minus 0.2 yn minus 2 plus
No,
xn
0.12. Wait, 0.12.
0.12 yn minus 2.
That's n minus 2, is it? Okay.
Yeah.
N minus
Plus xn.
plus xn.
And it says find the transfer function in dtft and find the 4-point dft of the transfer function.
Same story.
Yeah.
Let's take a z transform. You're going to get y of z equals the derivative, the z transform of this is going to be 0.7 z inverse y of z minus 0.12 z to the negative 2 y of z plus x of z. Do you understand this?
Yeah.
I took a z transform and this is like the standard
Yeah.
formula. Let me write down the formula for your reference. So if you have y of n minus a, and if you take a z transform, it becomes z to the negative a y of z.
Okay. Yeah.
That's the formula I've used here. Now what we'll do is let's club y of z, all of them together. So this is one y of z. So I took that one.
Okay.
And I'll take every y of z on the other side. I'll take this on the other side. I'll take this on the other side. Okay. Do you know this?
Okay.
So this will become plus 0.7 z inverse.
Yeah.
Plus 0.12 z to the negative 2. That's my y of z.
Yeah.
And on the right hand side, I've got x of z.
Yeah.
Now let's write down this as y of z over x of z.
Okay.
This is 1 over 1 plus 0.7 z inverse plus 0.12 z to the negative 2 multiplied by z square. So do you know z over x of z?
It's h of n.
H of z.
H of z. Okay. Yeah.
We'll get this as z square divided by. Okay, we can find out roots of this. Okay, first let's write down as z square plus 0.7 z plus 0.12.
Okay.
All right. And once you get it in this form, can we find the roots of this? Do you have a calculator handy? I have. So let's find the roots, equations, unknowns.
You have yours?
One, I have it.
Okay.
0.7, 0.12, negative 0.3 and negative 0.4 are the roots.
Okay.
Okay. So now if I find the roots, it's going to be z square divided by 0.3 and 0.4. Z plus 0.3 and z plus 0.4.
Okay.
That's the value of h of z. Now, I don't know if you remember this, but then we can do a simple adjustment over here and write h of z divided by z equals z over z plus 0.3, z plus 0.4. I just split the z square and took one of the z in the denominator.
Okay.
So I have z to the 1.
Okay.
And one
So
z.
in this case, we don't have to do the partial fraction decomposition, right?
You have to, right?
Oh, you still have to. Okay. So it makes it easier though if you split it. Is that why we do that?
Yes. Now we'll do the partial fraction expansion to this one.
Okay.
This adjustment is very important though. You will always get it in this form.
Yeah, because I know some people like when I was last exam, some people did this part, the partial fraction expansion, a little bit different because they didn't split the z down that way. Does it make it easier when we split the z this way?
Yes.
Okay.
I'll just show you what I mean by that in a minute, in a bit. H of z over z is going to be, and what you're saying is correct. Z plus 0.3 plus b divided by z plus 0.4. This is by PFE.
Okay.
So when I do partial fraction expansion, I get this.
Okay.
Now I have to find out the value of a and b.
Yeah.
Okay, so if you want to find out value of a, I gave you my shortcut, right?
Yeah.
Find the value of a, you have to hide this.
Yeah.
because the denominator of a is z plus zero point 0.3.
So then it's going to be negative.
Yeah, so we hide that, this whole thing,
Yeah.
and put z equal to negative 0.3.
Okay.
Becomes, this will become negative 0.3 divided by my negative 0.3 plus 0.4,
Okay.
which is negative 0.3 divided by 0.1, which is just negative 3.
Okay.
You get it?
Yeah.
So the value of a is negative 3.
Okay.
So a is negative 3. Now for finding b, you have to hide this. The denominator of b is z equals z plus zero point 0.4. You hide this
Mm-hmm.
and then put z equals negative 0.4. This becomes negative 0.4. This is negative 0.4 plus zero point 0.3. So you'll get negative 0.4 divided by negative 0.1, the sum of these two, and that's just
Yeah.
4.
Okay.
So that's the value of b.
Okay.
So I got b as well. B is 4. Now, as soon as you find these values, now just get your z back, like this z, take that back onto the other side. So you
Okay.
will get, then you will get h of z equals negative 3 z over z plus z plus zero point 0.3 plus 4 z over z plus zero point 0.4.
Okay.
And the now the reason why we took that z on the other side, because this has a nice formula to solve.
Okay.
Do you remember a to the n un? The z transform is z over z minus a.
Yeah.
So I can always take the inverse z transform and go back here.
Okay.
So in that case, the inverse z transform using this formula is going to be h of n equals negative 3. The inverse z transform of this thing is going to be 0.3 to the n un plus
Okay.
4 point, oh, wait, it's negative 0.3. You see z plus 0.3, that's z minus a, right? So when it's
Mm-hmm.
z minus a, it becomes a. So if it is z plus a, this should become negative a.
Okay.
So that way we have z plus 0.3. So that becomes negative 0.3 to the n u of n. And then this will become negative 0.4 to the n u of n. Now this is your h of n. Well, this is your impulse response. And by this time, you should see whether the question says causal system. Is it a causal system?
No, it doesn't say that.
So we have to assume that it is causal.
Okay.
Assuming causal. If we don't assume causal, then there are too many cases, like 2 more cases that you have to take into consideration. So if that is the case, just assume causal, okay?
Okay.
Okay. So now once you do that, what is the next thing that they're asking for?
Well, so it says find the transfer function in DTFT and find the 4-point DFT of the transfer function.
Okay. First of all, DTFT is Z transform at R equals 1.
Okay.
DTFT is Z transform at omega is Z equals e to the j omega. Z equals R e to the j omega and R is 1. That's DTFT.
Okay.
So we already have Z transform, do we?
Yeah.
Yeah, it's over here. It's over here, or it is over here as well. It's over here.
So what is this? So what is the other stuff that we just did right now?
Oh, I'll get back to that. Let's complete this first. I forgot to write about this previously.
Okay.
So now this is Z transform. Is this a Z transform?
Okay. Yeah.
We just took a Z transform steps over here. And this is a nicer way of Z transform.
Yeah.
you want DTFT, like that is what I just explained to you in the previous case. Now, if you're finding DTFT, okay, you're just replacing Z with e to the j omega.
Okay.
So what would that be? DTFT, the answer of DTFT is going to be
So
what?
instead of h of z, it's going to be h of e to the j omega.
Correct. H of e to the j omega.
Okay.
Or some people would like write it as h of omega.
Okay.
And the answer is going to be 1 over 1 plus 0.7 e to the negative j omega.
Okay.
Then tell me, next one would be 0.12 e to the negative j2 omega.
Yeah.
That's it. That's one of the answer we've got already.
Okay.
I just wanted to get it. I just forgot to write. It should have been written over here only. But anyways, okay.
Okay.
So assuming causal, we already have h of n. Okay. Now let's find 4-point DFT.
Okay.
So now to find 4-point DFT, do you know h of n has UNs? Do you see h of n as UNs?
Yeah.
And for UN, it is like this. N goes from 0 to infinity. And the value of U of n is just 1 all over. Till infinity, the value is 1. That's
Okay.
what n is. Okay. So what is going to be the value of h of n when n is 0? When n is 0, U of n becomes 1.
Mm-hmm.
This also will become 1. And you just put n as 0 here. And put n as 0 here as well. So you get negative 0.3 raised to 0, which is 1.
Okay.
And this is also 1.
Why is it on the graph that you drew? Why is it always at 1?
That's a standard signal.
Standard. Okay.
U of n is a standard unit step signal.
Okay.
It's defined to be like this.
Okay.
All right. So now once we raise it to 0, you get negative 3 and plus 4.
Okay.
Yeah. So what is negative 3 and plus 4 going to be? 1.
3 and plus 4, 1. Yeah.
Okay. Now let's put n equals 1. For n equals 1, un is still 1.
Yeah.
So h of n is, let's write better. Let me write it all proper. At n equals 0, h of n becomes, help, negative 3, negative 0.3 raised to 0, u of n is 1 plus 4. Are you getting what I'm saying?
Yeah. Yeah.
Raised to 0, u of n is again 1. And the answer was 1.
1. Yeah.
Now you tell me at n equals 1, h of n will become negative 3, negative 0.3 to the 1. U of n is anyways 1. This term is 1, right? Don't worry about
Yeah.
this. It's going to be 1. This is going to be 1 anyways.
Yeah.
Okay. Tell me. Plus 4, negative 0.4 raised to 1. This is 1
Yeah.
again. So you get this as, now you have to solve. Negative 3 into negative 0.3 is going to be positive 3 times 0.3. That's 0.9, is it?
Yeah.
3 times 0.3 is going to be oh. 1 minute. Of course, 3 times 0.3 is going to be 0.9. Okay, so this is plus 0.9, the first term. Tell me the second term. 4 times 0.4. It's 1.
Negative 0.616.
Is that positive or is it negative? Negative.
Negative, right? Yeah.
Yeah, negative 1.6. So now we have to find 0.9 minus 1.6 is that's negative 0.7. And then at n is equals to 2, h of n equal to minus 3 minus 0.3 squared plus 4 minus 0.4 squared. Do you see n became 2? That's
Yeah. Okay.
So let's do this. We're gonna get 0.3 square. 0.3 square would be 0.09, and times 3 is going to be 0.27. Negative 0.27. Then 0.4 square is 0.16 times 4, 0.64.
Okay.
Plus, can you also solve? I tend to make a lot of mistakes. That looks good, but anyway, so 0.64 minus 0.27. Please recheck these answers again later on when you solve. This is
Okay.
0.37.
Okay.
N equals 3, you will get h of n equals negative 3, negative 0.3 cube plus 4, negative 0.4 cube equals. Okay.
Okay.
Well, so 0.3 cube is going to be 0.3 cube is 0.027 times 3 is going to be this is going to be positive 0.081 plus, that's going to be minus now, isn't it? This is 0.4 cube, that's 0.064 times 4 would be negative 0.256. Okay, so you get 0.081 minus 0.256. Whoa, so that's negative 0.175. All right.
Okay.
So what we have achieved just now is we found out h of n in a 4-point form, which is 1, negative 0.7, 0.37, negative 0.175. This has got n equals 4.
Okay.
What are we supposed to find out yet? What is remaining yet?
I think that was it. It was to find the 4-point DFT of the transfer function, and this is what we just did. So they just wanted the DFT, the DTFT, and the 4-point DFT.
So we got the answer for DTFT.
Yeah.
We haven't got the answer of DFT yet.
Oh, okay. I thought this was the 4-point DFT.
Yes. So we've actually prepared our h of n for that.
Okay.
And we have to find out now 4-point DFT of this. So for h of n, can you read this? H of n, if you take a DFT, is it visible?
Yeah. Yeah.
It is x of k. And we are supposed to find x of k.
Okay.
So I'm just going to use the easier number so that solving becomes easier.
Okay.
And then you later on solve on your own. And that time you use the exact numbers.
Okay.
So the exact numbers that we are supposed to use are 1, negative 0.7, 1, negative 0.7, 0.37, and what else?
Negative 0.175.
But let me take the easier example. Supposing if your h of n, say, would have been 1, 2, 3, 4.
Okay.
And the question is find h of k. If you're supposed to find h of k. Now in this case, the way of finding DFT, there is a quick shortcut to find DFT. You draw 4 lines. This is called as a butterfly diagram. Have you seen this in the class?
No.
Then you draw 2 crosses. Then you connect first and the third line. And then draw a parallel line like this. Then connect first and the third line. And draw a parallel line like this. All right. Then all the cross will have, this is a standard structure. It can be derived, okay? We are not doing the proof. I'm just telling you how the graph works. So for the cross, you'll write down -1 here. For the cross, you will write down the -1 here. For the cross, you'll write down the -1 here. And for the cross, you'll write down -1 here. And then there is -j. This side you give it input as x of n, or say h of n, and this side you get output as h of k.
Okay.
All right. So the values of h of n are h of 0. Then you don't write h of 1, you write h of 2. Then h of 1, then h of 3. If you ask me why, there is a whole big theory and story and derivation and all that. But as of now, you just remember that we write evens here and odds here.
Okay.
But then the answer comes straight.
Okay.
Okay, so now you tell me what is h of 0. Now that is n equals 0, 1, 2, 3 are the values of n. So this is h of 0. And h of 0 is 1 in our case.
Okay.
Then h of 2 is this. That's n equal to 2. H of 2 is 3.
Okay.
H of 1 is 2. And h of 3 is 4.
Okay. You know what? This does look kind of familiar, actually.
You probably have seen it in the class.
Yeah.
So now this is basically called as a flow graph, and you have to just like flow across. So that this joint is where you add these numbers. So 1 flows and reaches here. And 3 flows and reaches here. And they get added up. 1 and 3 is 4.
Okay.
Then 1 and negative 3, 1 comes here as well. And then the 3 gets multiplied with -1 while it flows from here. It's like a flow graph or an algorithm. So you get 1 and negative 3, and then they add up to give you -2.
Okay.
Then you get 2 coming from here, and 4 comes from here. 2 and 4 is.
Why does 2 skip that first line going down?
Oh, it went here as well, right? It will go now eventually. Now the 2
Okay, so
as well.
order doesn't matter.
No. Yeah, the 2 will go here as well as here.
Okay. Okay.
When it goes here, it will add up with say 4 and it becomes 6.
Yeah.
When it goes down this way, it comes here, it comes 4, and 4 times -1 is going to be -4. So 2 and -4 is going to be -2.
Is it always minus? Is it always -1 on the bottom of the crosses?
Yes. Like the small crosses as well as the big crosses.
Okay.
And then your 4 will flow through and reach here as well. And then 6 will flow and reach here. And then 4 and 6 will become 10. Like this joint is where it is getting added up.
Okay.
Then this -2 times -j is going to give you 2j.
Okay.
And then this -2 will flow in, and it will become -2 plus 2j.
Okay.
Then this 2 will flow. This 2 will flow. 1 minute. No, this 4 will come here, and this 6 will come here. And while coming onto this, reaching this point, it will get multiplied with -1.
Yeah.
So that becomes -6, and this becomes 4.
Okay. So -2.
4 is going to be -2.
Okay.
And then this will be -2 coming down here. And then this 2j gets multiplied with -1, and you get -2 minus 2j. This -2 reached here. Then this 2j get multiplied with -1, and that becomes -2 minus 2j.
Okay.
And this is my final answer.
Okay.
And that is what you call it xk, or say hk, because we're calling it hn.
But what's the difference between this way and the other way that we did previously?
Wait a minute. So answer is 10 -2 plus 2j -2 -2 minus 2j. This is the final answer. This is for k equals 0, k equals 1, k equals 2, and k equals 3. This is the final answer.
Okay.
Okay. This is the shortcut way. By the way, this is called as FFT, fast Fourier transform.
Okay.
And it says fast, so it is actually fast.
Okay. So So DFT and FFT are the same?
DFT and FFT are the same, except FFT is faster.
Okay, but you get the same result.
You get the same results. Yeah.
Okay.
Do you remember, like last time we have done the similar problem, but instead of finding a direct h of k, we have got this similar answer. Do you remember I told you that when this is plus, it's going to be a conjugate? You remember that? This is plus and this is minus. Did I tell you that k equal to 3 answer is ready-made? You don't have to solve.
Yeah, I remember. So yeah, okay.
The last question I said the same thing, right? I asked you to solve on your own and see if the answer will be this only. If it is minus 2 plus 2j, this has to be minus 2 minus 2j.
Okay, so the inner expression is gonna just be the opposite.
Yep.
Okay.
There is some property like that, but it's not really asked, so we'll not get into detail of that.
Okay.
Okay. So this is how the answer is, and I believe now we have the answer full ready. But except that instead of using these numbers, I have used the simpler numbers.
Yeah. Okay.
Then the calculation becomes easier.
Okay.
And I'm sure these answers are correct. So now you have to do this on your own. You have to take these numbers and plug in those numbers here, and do exact same thing. You will get the answer.
Okay.
This is question 7.
Okay.